name's Alex Kaufman. I'm the inside sales manager. If you've had any sort of service contracts or small orders, hopefully you've talked to me at some point. That's kind of what I'm doing right now. But other than that, you're probably wondering, like, who is this guy? What has he done before? That's IT related. Well, by way of real brief introduction, I grew up in Washington State, Redmond, Washington, home Microsoft. Kind of grew up with laptops and computers. I was kind of an IT department for my dad's home business there. And I met this guy who got me really interested in biology, and I went and he's actually the former chief software architect at Microsoft, by the way, and so he comes into the story later. I went to school at Duke in North Carolina, so moved out there, studied biology for a while. I went back to Edward over there's company, Intellectual Ventures, as an intern, and changed my major to economics. I graduated and decided to just start my own business, working as on a contract basis for him, actually doing patent brokering. So I got to broker a few deals out in North Carolina that got 32 patents that totaled up to over value of over $3 million, and that was great. That was really cool. And I got married right around the same time to my lovely wife Carolyn, who's here, and she grew up in Texas, so here I am. And not shortly after I moved, I met Steve and David, and they invited me in to the Fulcrum group, and I'm very, very happy to be a part of the team. It's a very cool company. So the theme tonight that I really wanted to kind of, or the metaphor, I guess, that I wanted to bring home is that computing, or cloud computing rather, is becoming a shared and on-demand utility. Kind of like water and the water supply system, but instead of water, you've got data. So, and the reason it's on demand is because when you turn it on, it's there for you. You don't have to pay for it. There's really no upfront cost to your water, and shared, of course, because it's coming from a central source. So when I started and knew what the theme was going to be, cloud computing, I kind of went to the whiteboard and did a little brainstorm, and I was trying to figure out, okay, how do we get here? How do we get to where we are now to cloud computing? And it's just a rough sketch, but we started out with mainframes, and people, in the 70s, as recently as the 70s, standing in line with their punch cards, and I didn't use punch cards, but I heard stories, yeah, and then I know about Moore's law, and Moore's law shrank everything down, made everything cheaper, faster, and smaller, and we had the great PC revolution. Everyone had a computer on every desk, and the transition then was really the internet, and everyone started connecting these disparate PCs back up. And then at that point, it seemed to me like there was really a reaggregation of compute power. And that's really what we're going to talk about today, is that cloud computing happens in these big aggregated server farms or data centers, whatever you want to call them, that have been managed and are energy efficient and all these great things. And I just thought it was kind of neat that we kind of have some similarities between where we are today and where we used to be, and that these things take up whole buildings just like those old mainframes do. So my thought about how to really boil it down to something really simple to talk about would be to go back to something everybody understands, PCs. And I had a PC back when I was 7 years old, actually, in 1992, pre-cloud. And my PC was, some of you were going to cringe, was a Packard Bell 286. And, oh man, I thought it was cool at the time. But 64 kilobytes of RAM and 8 megahertz chipset, and, those old floppy drives that were actually floppy, that was really cool. And the good old days, computers couldn't beat us yet at Jeopardy, so, that's good too. And so the reason I'm going back to this is that the real basic idea that I thought was important about cloud computing is the idea of computer sharing. And even on a simple computer like this, you're going to have computer sharing. And I did with my brother, when I was on the computer, I was playing the old DOS games like Commander Keen. And my brother would come in and kick me off and say, hey, I'm going to play Rita Rabbit. So this is basic computer sharing, just taking turns on the PC. And why did we do it? Because parents were going to buy 2 computers. And we've got to take turns on just the one. And this is basic economics, efficient use of scarce resources. And when you share computers or computing resources, there are cost savings, particularly upfront cost savings. And so, you might say, that's just taking turns, that's not really computer sharing. Well, even on a single PC, you can do simultaneous computer sharing. There's still tools out on the market that allow you to do kind of desktop multiplication. And you can kind of see pictures here where these are all dummy terminals here, and they're just hooked up to one PC. And of course, the reason you wouldn't want to do this is get 4 people on there, their performance gets really, really bad, right? Really sluggish. And you're all kind of looking at this point maybe and saying, well, where is he going with this? I mean, this is supposed to be talking about cloud computing, it's talking about PCs. Well, maybe the government can just tell us what cloud computing is. Here's a formal definition that they came up with from the National Institute of Standards and Technology. I'm going to read this out loud here. Formal definition is, cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, e.g. network service, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. This cloud model promotes availability and is composed of 5 essential characteristics, 3 service models, and 4 deployment models. Cross-eyed yet? Okay, well, but there's more. Okay, they said 5, 3, 4. Okay, here they are. Oh, shoot. Okay, all right. On-demand, self-service, resource pooling, rapid. Okay, all right. Oh, shoot. It just gets even finer. Oh, man. I mean, just good grief. I mean, let's skip that and let's talk about what it really is. Let's go back to our heroes, back to the story. Still just 2 kids, but now the other kid is on the other side of the planet, and we're going to introduce internet into it and say that we can have good connectivity. And let's say that I'm over there and I've got my PC and I've got great internet and got an email from someone in China and he says, hey, we don't have games here. I can't buy games here. I can't buy Commander Keen. So he says, can I log into your computer at night when you're sleeping and play your games? I say, sure. And then I get an idea. Can you send me some money every month? I'll buy more games, and then you can play it while I'm sleeping. We just keep doing this. What I've got is a tiny, tiny version of a public cloud. And I'm providing software as a service. And I got a happy customer and a really cool business model. So that's the closed loop there. And all you got to do to understand cloud computing now is to think a lot bigger. A lot bigger. Millions, billions of users renting compute power at one time, and much more efficiently. Now, how big? I went to a cool website, I'll reference it here, datacenterknowledge.com. You should go check it out. I found the top 10 data centers built in existence in 2010 by square footage. So number 10 is SuperNap in Las Vegas, 407,000 square feet. And data is actually pretty heavy when you put it all in one place like this. Microsoft's San Antonio, Texas, and Quincy, Washington data centers are both 470,000 square feet. DuPont Fabros in Elk Grove Village, these are actually cooling systems for the processors and server arrays that you see. You don't even see the arrays themselves, 485,000 square feet. Phoenix One in Phoenix, Arizona, 538,000 square feet. You kind of see the arrays here and the trays of cables going out to them and the causeway there. And Microsoft Global Data Center in Dublin, Ireland, probably like servicing all of Europe and whatever, and that's 550,000 square feet of space for servers. Microsoft Chicago Data Center in North Lake, Illinois, 700,000 square feet. This one's kind of neat. Steve and I were talking about it because they actually have container systems there where they've used shipping containers and filled them with servers, and they're modular. And they just bring them in as they need them, and they bring them other places. And the NAP of the Americans in Miami, Florida, it's used by the Department of Defense, 750,000 square feet, and can survive a Cat 5 hurricane. And Next Generation Data in Europe is also 750,000 square feet. It's in Wales. QTS Metro Data Center in Atlanta, Georgia. Georgia, we're getting really big, 990,000 square feet. And then this is the biggest one as of April 2010. It's the Lakeside Technology Center in 350 East Cermak in Chicago, 1.1 million square feet. And it's this older building that was used for something else. I think it might have been a newspaper or something, and they gutted it completely, so it's got this Gothic facade and they filled it with servers. So what's the point of all this? The point is that there was an origin to the word cloud, and I want to talk about that real quick. It's an interesting story I found online. The word cloud comes from when network engineers have drawn their diagrams, at least this is one origin story or myth, however you want to take it. When they're drawing their diagrams, they have to like represent the internet somehow. And so they represented it with a little cloud. It was sort of like this area that they didn't understand. It was this unknown domain. And you can kind of understand why you wouldn't understand it, because these massive, complex centers are behind it. And so found this guy, but he's saying he originally symbolized an unknown network domain. So no wonder people are confused about cloud computing, what it is, because originally it was something you didn't know. But he says, please send your packets anyway to me. They'll get where they need to go. You don't have to worry. And then how efficient are we talking about? And that's the other question. When you start managing all these computing resources, you can get these things really, really efficient. Anyone know floating point operations? You know what flops are? Who's heard of flops before? Flops, okay, good. Floating point operations per second. If you do flops per watt, that's a good measure roughly of computing efficiency. The UNIVAC in 1951, the first commercial computer that did only 0.015 flops per watt. And in 2011, IBM came out with a supercomputer that was capable of 1.684 billion flops per watt. So we've come a long way. You can see it there. They're using it in some government laboratory. And then the data center is kind of interesting. They've got all these different metrics. It's like people, are just dreaming different metrics up for how to make a really efficient data center. You got DCIE, which is IT equipment, divided by total facility power, and SWAP, which is performance divided by space and power for Sun Microsystems. And then this one, I just thought this was funny because I couldn't even write the equation on here, so I just put that there. I'm just like, clearly there are some people whose only job it is to come up with these metrics for data centers. And that's a good thing, because what it means is that hosting and using these remote resources is really cheap and easy, and really efficient. And so I want to tell a little story about Web 2.0. I'm sure a lot of people have heard the buzzword Web 2.0. Now, a good way to explain this is if you're in a little niche industry, like garden gnomes. If you're a garden gnome manufacturer, okay? I can't think of many more niche industries. It's pretty niche. But you start developing some software, say, for internal use. You're just, just a garden gnome design software or something like that. And you start getting calls from all these other garden gnome manufacturers. There are however many, 3 others that are out there, and they're like, hey, we're willing to pay for your software. These are your former competitors. We'd really like to use it too. And you're like, no, I'm not a software company. I'm a manufacturer. But they're willing to pay. They say, just throw it up online, throw it up on one of those data centers, put it on a website, write it in JavaScript, whatever you have to do, and we'll send you checks every month to have access to it. Hey, congratulations, now you are a hip Web 2.0 company, serving garden gnome design community, as it were. So your distribution cost, basically just your web hosting bill every month, and that's going to be pretty cheap. And that's largely because of those big and efficient data centers that we just took a look at. And P.S., this is kind of why Mark Zuckerberg is like a billionaire. Because bill's very low, but you can charge very high prices for that software access. And so the result of this shift has been an ecosystem of web software that's essentially ad-supported. You can kind of see some of those more free different tools out there. Or enterprise offerings that are at a flat monthly rate, say, small businesses and what have you. So once again, this is just returning that original slide, Economics 101. We don't need to buy an extra couple of servers when we could go and share the resources that are out in the cloud. So and with that, I'd really just like to say, this is what we do at Fulcrum. I'd like to introduce David and Jeff to continue that conversation on the economics of the cloud and how to make that decision, because that's what we love to help you with at Fulcrum. And,
okay, appreciate it. All right. Well, when we talk about